extent can these thunderstorms sort of wrap around to the north? Remember, the wind shear that the storm is feeling is coming out of the west northwest. Again, even though there aren't any west northwesterly winds at any part of the atmosphere, but that's how the storm feels the wind shear here. And if these thunderstorms can wrap what we call up shear, then the system is going to be able to insulate itself a little bit more, and I'd expect to see development become a little bit more rapid. So that's one of the challenges the storm is facing, is basically aligning its low-level center with its thunderstorm activity. The other challenge that the storm has to deal with is a little bit of ever so subtle mid-level dry air. So you can see this is a neat satellite product that overlays some visible satellite imagery that we were looking at earlier with the lower water vapor band from GOES East. So this basically lets us take a look at the amount of moisture in the atmosphere. And you can see that there's this pocket of red that's sort of lurking off to the northwest of Sally. And if you look beneath the cirrus canopy, you can see that extends a little bit closer to the storm center. Again, the storm center itself is located right about here. So this mid-level dry air is inhibiting convective development on the northwestern side of the storm. And this has been especially true over the past couple of days as the air that's been wrapping into the northwestern quadrant of the storm has been sourced from over the Florida Peninsula. Remember that the air that's occupying the cyclone's inner core on the northwestern side originates in the outer bands on the northeastern side. So that's how we get this counterclockwise rotation. So basically, when the storm was down here, closer to the Florida coast, that air had spent quite a bit of time over the Florida Peninsula, during which time it had acquired no low-level moisture or heat from the ocean because it wasn't over the ocean. But now, as the system is gaining a little bit of distance between it and Florida, the air parcels that are coming into the northwestern quadrant there are being sourced from the Gulf of Mexico over here. And that means that they are able to pick up more moisture and heat energy as they're spiraling around towards the storm center. So between a little bit of relaxation of the upper level shear, and so on and so forth, I think that the system is poised to intensify, probably beginning later this afternoon, but really more tonight. And one tool that we have in our toolkit to figure out when this system might begin to pick up is some of the model guidance. Now, I'm pretty skeptical of model guidance, generally speaking. There's a saying in the meteorological community that all models are wrong, but some are useful. So let's take a look at a model that's certainly wrong, but potentially useful. So I'm going to go back to the 0Z run of the HWRF, which for those who've followed closely along with model forecasts, you know that there's a reason for that. And the reason is not because I endorse its landfall central pressure or maximum sustained winds, because of course those are very high. But the point is that if we're sort of doing a thought experiment here, what would need to happen, what could happen if the storm were to really take off in the last 24 hours before landfall? And note that convective organization tonight, at least according to the HWRF, is not a precondition for making landfall as a strong storm. So this is the forecast for 0Z, so that's 8 p.m. This evening, East Coast time, 7 p.m. Central. And notice here's the low-level center. Where's all the thunderstorm activity? Still way off, displaced from the storm center. There's a little bit trying to wrap around, but this is a system that basically by tonight is still looking a whole quite a bit lopsided, I guess is the right way to say that. And nevertheless, that does not seem to slow it down, at least according to the HWRF depiction of this, which I think is somewhat realistic. Basically, as the system moves northwest, we see a relaxation of the shear a little bit, and we can analyze that in a little bit more detail using these storm average soundings. So we're just going to take a sounding over the whole storm and see what it's telling us. And basically on this sounding, which it by taking a sounding that's average over that whole area, we subtract out the cyclone circulation. We're left with just the environmental flow. And the environmental flow you can see here is out of the east-southeast at about 10 knots in the lower levels, and it's doing absolutely nothing. This is dead calm through the mid-levels. So the low-level center is moving west-northwest at 10 knots. The mid-level center is going absolutely nowhere. So relative, in the sort of storm relative sense, you're getting 14 knots, thereabouts, 10 knots, 14 knots of shear out of the northwest. That's what's happening this evening. It's still expected to continue this evening, even in a model depiction that's showing explosive intensification later on. So let's see what happens a little bit later down the line as we move into tonight. As we move into tonight, you can see that now the model is expecting, or at least it was expecting in this run, that convection to be wrapping around over to the northwestern side of the system. And that's really the key ingredient here. You got to get that convection to wrap what we call up shear, or towards the direction from which the shear is coming. Once you do that, storm will be doing a lot better. So how do we get that convection to rotate up shear? Well, best thing we can do is reduce the shear, make it easier for the storms to get up shear. And that's pretty much what we see here from the HWRF. Although interestingly, this sounding at this frame doesn't really show that. It shows more shear. But as the storm moves underneath a little bit of a mid to upper level ridge, it's going to start to see that shear drop ever so slightly. And that could allow for that convection to wrap up shear a little bit more. If that were to happen, storm could intensify fairly quickly. So one thing to keep an eye on from a track perspective is that shear profile is actually going to be impacting the storm's track forecast and in a fairly interesting way. So we can see that by comparing the 12Z HWRF, which is relatively weak, with the 12Z HMON, which is a sort of subvariant of the HWRF. It's a little bit different, but mostly the same. And comparing to see how they differ in their track forecast. So the HWRF, the new run from this afternoon, not nearly as bullish with the storm's intensity. Takes it along a track somewhere like this, right over or just east of New Orleans. This would put the worst of the storm's impacts here along the southern Alabama and Mississippi coastline. Now, the storm is taking this west-northwest track because, remember, that's what the low-level winds want the storm. That's where the low-level environmental winds are pushing the storm off to the west-northwest. And if it remains weaker, it will feel the influence of those low-level winds more strongly. But if we take a look at the GFS model, I know we're switching between a lot of models here, but we do our same area average sounding on the GFS, and we will see that the steering flow is quite a bit different if you head towards different levels of the atmosphere, which is a relatively weak storm. You're moving off to the west-northwest or perhaps northwest at, say, 10 to 15 knots. If you're stronger, you're taking the average of a deeper layer of the atmosphere. And notice that the winds up here are out of the west, right near 500, 400 millibars. So that's basically, the low-level center wants to go west, the upper-level center wants to go east. That's shear in and of itself, but it also means that the steering flow, which is the layer average of all these winds, is much slower, right? Because you have the westerly component, the easterly steering component of the low-level winds is getting canceled out by the westerly steering component of the upper-level winds. So all that to say that if the storm ends up stronger, and if it ends up much stronger, it'll start to feel these southwesterly winds near the top of the atmosphere. So a stronger storm is going to be moving more slowly, and it's likely also to curve off towards the north faster because it'll feel the influence. There's this upper level trough over atmosphere. So a storm has to be strong if it's going to feel that steering influence and do that recurve off to the north. If the storm's weak, it has no idea that upper level trough is there, and so it'll just sort of keep going and die out over western Louisiana or something. If it's sort of mid strength, I guess, which would be like a strong tropical storm or a low end hurricane, it's just going to sort of dawdle here. and not really go very far very fast. That's really the scenario I'm probably most concerned about, because I'd really influence or bring up the rainfall and the surge projections especially. So all right, that's a little bit of a look at what the system's doing right now. A little bit of an insight into this storm's track and intensity forecast. Really, I don't have a whole lot else to say other than we're just going to keep our eyes basically glued to this satellite imagery. There's a Hurricane Hunter plane in there now. They found there's the low-level center, basically right on the south side of that new convective burst we mentioned at the top of this discussion here. So plane's going back through. It's going to make a pass from southwest to northeast. We'll see what it finds, but basically, we're just sort of watching and waiting to see the if that thunderstorm activity can pivot back to the northwest of the cyclone center. And you can see it's trying, right? It's trying to wrap up Shear to move in that direction, but it hasn't quite gotten there yet. So that's it for me for now. I'll have an update up on the Patreon page later this afternoon, and I'm sure I will be back on the live stream at least a few more times in the coming days as we watch Sally move towards the Louisiana coastline. All right, that's it for me for now. Thanks everyone for watching, for supporting Mark's work here. I'm very excited to see all the footage from the cameras down there and the data that he and the rest of the team are able to get. All right, see you later.
It's Scott from Colorado. He's back and he was out of town.